Hello, my name is Anthony Sempt, and this is Physics 2212, Lab 2. So in this lab, I'm going to be giving an introduction of this week's experiment, followed by a more in-depth description of the initial conditions and some assumptions, followed by a computational model that represents what we discussed and in the intro and description, and then finally I'll conclude it with some possible error and some analysis. So going into this lab, we are trying to create a more accurate computational model than what we did in Lab 1 by using a distributed line charge instead of a point charge. I'm going to be using the data that I collected in Lab 1 along with a new GlowScript code. And just a little preview of my results, I found that the charge was about 10 times greater than in Lab 1 at 1.48 times 10 to the negative 7 coulombs. So some fundamental principles that are very important to this lab is going to be Coulomb's law, and from Coulomb's law we get things like the electrical field formula, which is essentially what we have there, just one of those Q values is not represented. Newton's second law, it's important to know that at equilibrium, F net equals 0, so in this lab that's going to mean that the force of gravity is equivalent to the force of the electric charges. It's important to know that we are using distributed charges instead of point charges, and that energy is conserved because that applies to the charges on the particles as well. So some assumptions that I made in this lab: all tapes are going to have the same uniformly distributed charge, and I'm going to assume that air resistance is negligible, and we'll talk about why that maybe isn't a great assumption later. And naturally, the tapes can no longer be considered point charges in this lab. So a high-level overview, like I said, F electric equals F gravity, and in Lab 1 I determined that the charge on the tape was positive. So clearly defining the system and surroundings here, we have two pieces of tape. It's going to be the system, and the surroundings is everything else. So in this experiment, like I mentioned, we used the same procedure as Lab 1. So in Lab 1, we observed the interaction of household objects, tape, and their ability to float above one another. And I calculated that the charge on one of those pieces of tape was 1.4 times 10 to the negative 8 coulombs. So some of the procedures from that lab was that I took the charge of those tapes and determined the sign by observing some interactions with other household objects, and I said that it was positive. So then I caused one tape to float above another using their repulsive forces and measured the distance, which I found to be 0.3 meters or 30 centimeters. And I used the tape length, tape mass, and the distance between those tapes to do some analysis. And that analysis was mainly finding the excess charge, which on the right-hand side of the screen you can see is 1.4 times 10 to the negative 8 coulombs. It's also important to note the gravitational and electric force that I have calculated there, because that's important for the computational model that's next up. So here you can see my GlowScript code that was provided as source code by the professors. You can see on line 25 my new estimate for Q, which is important for really the results of this experiment. Finally, on line 34 to line 41, you can see the new, or I guess not new, the formula to calculate the electric force. On this slide, this is a more in-depth view of all the things that I changed. There's not much, and there's a lot of kind of craziness going on, but essentially I'm playing around with the forces and the arrows. That's going to be a little bit easier to see on the next page. So here we have the actual results of the model. In white, there's the electric force, which is pushing up because it's repulsive. The red and blue lines of dots are the two pieces of tape. The yellow line, the yellow arrow rather, is the force of gravity pulling that top tape down, and those green lines are the individual forces, electric forces at those points. So as you can see, they're not all pointing perfectly straight, which is kind of important for some analysis that I'll get into next. But then you can see that the magnitude of the electric force and the gravitational force are equal. So in this lab, there were a few sources for error. First, there were some estimates made, like I mentioned. So there were some scale factors that are also important that could have contributed to some error. When handling the tapes, making them float above one another, I might have touched it a little bit and caused some of that charge to dissipate. And then finally, in a room, air flows, so it might affect the tape in some way because tape is very light. So air resistance maybe shouldn't be neglected completely. It's just hard to measure. So what if the tape was modeled as a single point charge like it was in the last lab? Well, then we would have the same results as the last lab. If it was modeled as 1 point charge, we would have a higher value or a lower value of Q, and it wouldn't be as accurate, which answers the second question. Treating this as a line charge is much more accurate than treating it as a point charge, because in reality, it's a point charge. Or it's a line charge, not a point charge. That's all I have. Thank you for watching, and have a nice day.